Hi, I'm Paul Pasolka, Ivy Masters Learning Center and ivymasters.com. And today we're going to look at Test 1, Section 4, number 29. Before we do, Thursday 6 to 8 class, you had questions about Test 1, Section 3, numbers 13, 14, 15, 17, and 19. We have videos shot on all those. Just click on videos on the YouTube channel and just search the number and you'll find those videos. So for number 29, it reads, for the polynomial p of x, p of 3 is -2. Which of the following must be true about p of x? So what I'm going to do is I'm going to make up a polynomial where p of 3, meaning plugging 3 in for x, will give you -2. So, and that polynomial is going to be, let's say, p of x equals 2x squared plus 3x minus 29. Now, where did I come up with that? Well, when I plug 3 in here, I get -2. So if I do 3 squared here, I get 9. 9 times 2 is 18. 3 times 3 is 9. 18 plus 9 is 27. Minus 29 will give me -2. So it works there. And then I could test this out with the answer choices. Now, in order to check if something's a factor, then how it will actually work is x minus 5. I should be able to literally factor that with x minus 5. But check out the -29 here. 5 doesn't go into 29. So it's not going to be answer choice A. Now, let's say I check out answer choice B. X minus 2. 2 doesn't go into 29. So answer choice B is wrong as well. And for the same reason, answer choice C is wrong. So it must be answer choice D. Now, what I'm going to do is I'm going to show you a different approach to proving that D is correct. And that is long division. And I could have done long division with the others, but typically it's more time consuming. So if I've got my 2x squared plus 3x minus 29, and answer choice D is saying the remainder when it's divided by x minus 3 is -2. If I do x minus 3 in there, I get actually 2x on top, multiply it out, you get 2x squared minus 6x. And then subtracting, you got to change sign, edit down, these cancel, you get 9x minus 29. And then x goes into 9x, 9 times, add the 9 there. When you multiply, you get 9x minus 27, change sign, you get -2. Sure enough, when you divide x minus 3 in, you get -2 as your value. So, we've just proven that answer choice D is your correct answer. So there's a concept here that could be helpful to you, which is, I'm going to erase all this, which is, if I were to, let's say I made a polynomial with these two. So I did x minus 5 times x plus 2. What I get is x squared minus 3x minus 10. And then notice it factors as x minus 5 and x plus 2. When you add -5 and +2, you get your -3, which is your middle term. When you multiply those two, you get -10, which is your last term. Now, this is the same thing as if I were to divide them. So if I divided x minus 5 into this, what I would wind up with is x plus 2 up top. Check it out. X multiply, you get x squared. Multiply, you get minus 5x. Change sign, that's your subtraction. These cancel, you get 2x minus 10. And then how many times does x go into 2x? It goes in twice, so you got plus 2. Multiply, you get 2x minus 10. It matches. Change sign, both cancel. You can see x minus 5 goes in x plus 2 times. And if we divided x plus 2 into it, it would go in x minus 5 times. The same thing as a fact family that you did back in the day with like 3 times 4 is 12, 4 times 3 is 12, 12 divided by 4 is 3, 12 divided by 3 is 4. Okay, so got that. So what happens is notice if x minus 5 is a factor, then dividing x minus 5 in, it's going to go in evenly. If x plus 2 is a factor, then dividing x plus 2 in will go in evenly as well. Not only that, but if I took that formula that expression that I had before, which is x squared minus 3x minus 10, and if x minus 5 is a factor, what that means is that 5 will yield 0 when I plug it in here. Check it out. 5 squared minus 3 times 5 minus 10, and I get 25 minus 15 minus 10, and I get 10 minus 10, and it gives me 0. And the same thing, if I plugged negative 2 in here, I would get a 0 as well. So anytime something's a factor, what you do is you plug in, you could think of it as you plug in the opposite and you get 0 as a remainder. That's if it's a factor. But what happens if it has a remainder? Then when you plug a number in for it, let's say p of 3, if your remainder is negative 2, then that means when you divide x minus 3 in, your remainder is going to be negative 2. Vice versa, if you long divided x minus 3 into, like this expression right here, you'd get negative 2 as a remainder. That's the same thing as saying p of 3 is negative 2. So those work back and forth like that. This is a more complicated concept, so if you lost it, this might be the one that you let go. You know, you unless you're scoring 750 or above, this question in particular, you might just let go. Thank you for joining us today. If you like this video, click like. You could share it with someone who has trouble with polynomial functions and divisibility. If there's any question you'd like to see from any official PSAT or SAT or ACT, leave that in the comments. I'd be happy to shoot a video on it. And click subscribe so you don't miss anything. Have a great day.